Hello everyone, welcome to the course on chemistry. In previous video, we have solved some problems on states of matter. Now it is the continued part, and today also we will solve some problems on new concepts and the questions which are asked in the previous competitive examinations. So let us study one by one these questions. First one, the atmospheric pressures recorded in different cities are as follows. Cities names are given and the pressure is also given. In Shimla, it is 1.01 into 10 raised to 5. In Bangalore, it is 1.2 into 10 raised to 5. And in Delhi, it is 1.02 into 10 raised to 5. And in Mumbai, it is 1.21 into 10 raised to 5. Consider the above data and mark the place at which liquid will boils first. So ಇಷ್ಟು ಸಿಟೀಸ್ ಒಳಗೆ ಎಲ್ಲಿ ಲಿಕ್ವಿಡ್ ಭಾಳ ಫಾಸ್ಟ್ ಆಗಿ ಬಾಯ್ಲ್ ಆಗುತ್ತೆ, ಫಸ್ಟ್ ಯಾವ್ದು ಬಾಯ್ಲ್ ಆಗುತ್ತೆ? ಆಸ್ ಯು ನೋ, ದಿ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದಿ ಪ್ರೆಷರ್. Means as the pressure increases, the temperature will increases and also the boiling point will also increases. ಈಗ ಬಾಯ್ಲ್ಸ್ ಫಸ್ಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಪ್ರೆಷರ್ ಲೋ ಯಾವುದಿರುತ್ತಲ್ಲ ಅಲ್ಲೇ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ನು ಏನಿರುತ್ತೆ ರೀ, ಕಡಿಮೆ ಇರುತ್ತೆ. ಅದು ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಬಾಯ್ಲ್ ಆಗಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಅಮಾಂಗ್ ದೀಸ್ ವಿಚ್ ಒನ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ವೆರಿ ಲೋ ಪ್ರೆಷರ್, ದ್ಯಾಟ್ ಯು ನೀಡ್ ಟು ಫೈಂಡ್. ಲೋ ಪ್ರೆಷರ್ ಯಾವ ಸಿಟಿ ಒಳಗದ ರೀ? ಇನ್ ಶಿಮ್ಲಾ ಇಟ್ ಈಸ್ ಹೌ ಮಚ್? 1.01. ಶಿಮ್ಲಾದೊಳಗೆ ಎಷ್ಟು ಅದ ರೀ? 1.01. ಆ್ಯಂಡ್ in Bangalore it is 1.2, and in Delhi it is 1.02, and in Mumbai it is 1.21. So among these four, the Shimla is having the lowest pressure, and hence in that city the liquid will boils first. So option A is the correct answer, Shimla. Okay, then second question, increase in kinetic energy can overcome intermolecular forces of attraction. How will the viscosity of liquid be affected by the increase in temperature? ಈಗ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ ರೀ, ಹೆಚ್ಚಾಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹೌ ವಿಲ್ ದಿ ವಿಸ್ಕಾಸಿಟಿ ಆಫ್ ಲಿಕ್ವಿಡ್ ಬಿ ಅಫೆಕ್ಟೆಡ್ ಬೈ ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪ್ರೇಚರ್? ಸಪೋಸ್ ಈಗ ಟೆಂಪ್ರೇಚರ್ ಹೆಚ್ಚಾಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ವಿಸ್ಕಾಸಿಟಿ ಏನಾಗುತ್ತೆ? ಹೆಚ್ಚಾಗುತ್ತೋ ಕಡಿಮೆ ಆಗುತ್ತೋ ಅಥವಾ ಇಟ್ ವಿಲ್ ರಿಮೇನ್ ಸೇಮ್ ಆಗಿನೇ ಉಳಿತದೆ. ಆಸ್ ಯು ನೋ, ವಿಸ್ಕಾಸಿಟಿ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ದಿ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ವಿಚ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಬಿಟ್ವೀನ್ ದಿ ಲೇಯರ್ಸ್ ಆಫ್ ದಿ ಲಿಕ್ವಿಡ್. ಎರಡು ಲೇಯರ್ಸ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ನಡುವೆ ಇರುವಂಥ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ವಿಸ್ಕಾಸಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ಆ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಯಾಕಿರುತ್ತೆ? ಇಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್. ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಹೆಚ್ಚಾಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ವಿಸ್ಕಾಸಿಟಿ ಹೆಚ್ಚಾಗುತ್ತೆ ರೀ. ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಕಡಿಮೆ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ವಿಸ್ಕಾಸಿಟಿ ಏನಾಗುತ್ತೆ ರೀ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ಆ್ಯಸ್ ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದಿ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್? ಟೆಂಪ್ರೇಚರ್ ಹೆಚ್ಚಾಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಏನಾಗ್ತಾವೆ ರೀ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಡಿಕ್ರೀಸ್ ಆದವು ಅಂತ ಹೇಳಿದ್ರೆ ವಿಸ್ಕಾಸಿಟಿ ಏನಾಗುತ್ತೆ ರೀ? that will also decreases. So as temperature increases, viscosity will gets decreases. So which option is right? Option C is the right answer. Then third one, at a higher altitude the boiling point of water lowers because high altitude ಅಂದ್ರೆ ಹೆಚ್ಚು ಹೈಟ್ ಒಳಗೆ ಹೋದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ ಅವಾಗ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಆಫ್ ವಾಟರ್ ಏನಾಗತ್ತೆ ರೀ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಯಾಕೆ ಕಡಿಮೆ ಆಗುತ್ತೆ? Simply, as we move to the higher altitudes, the atmospheric pressure becomes lower. As atmospheric pressure becomes lower, the boiling point of water will also lowers, and hence the option A is the right answer. That is, atmospheric pressure will get lowers. The next question, fourth one, which of the following liquid will exhibit highest vapor pressure? ಈ ನಾಲ್ಕರೊಳಗೆ ಯಾವುದಕ್ಕೆ ಹೈಯೆಸ್ಟ್ ವೇಪರ್ ಪ್ರೆಷರ್ ಹೊಂದಿರುತ್ತೆ? ಸೊ ಹಿಯರ್ ದಿ ಇಥನಾಲ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ hydrogen bond, and NH3 is also having hydrogen bond. HF, that is also having hydrogen bond. H2O, that will is also shows the hydrogen bond. So among these four, which one is having the strongest bond? Strong bond ಎದ್ರೊಳಗೆ ಇರುತ್ತೆ ರೀ. ಎಲ್ಲಾದ್ರೊಳಗೂ hydrogen bond ಅದ, but among them which one is having the strong bond, that you need to find. Here the bond is formed between oxygen and hydrogen. Here the bond is formed between hydrogen and nitrogen, and here also bond is formed between hydrogen and oxygen, and here the bond is formed between fluorine and hydrogen. Among these four, the bond which is formed between nitrogen and hydrogen is weaker, since nitrogen is less electronegative and oxygen is more electronegative and fluorine is still more electronegative. So whichever is having low electronegativity, that will form the weak hydrogen bond, and hence the intermolecular force is weak. And as intermolecular force decreases, the vapor pressure gets increases, and hence this option B is the right one. Okay. The fifth one, the manifestation of surface tension is, surface tension ಇರೋದ್ರಿಂದ ಏನನ್ನ ಅದು ಶೋ ಮಾಡುತ್ತೆ? ರೈಸ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ಇನ್ ಎ ಕ್ಯಾಪಿಲರಿ ಟ್ಯೂಬ್. ಇದನ್ನ ನೀವು ಎದರ ಸಂಬಂಧ ನೋಡ್ತೀರಿ? ಡ್ಯೂ ಟು ದಿ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್. ದಟ್ ಈಸ್ ರೈಟ್. ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಆಫ್ ದಿ ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್ಸ್. ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್ಸ್ ಏನಿರ್ತಾವ್ರಿ? ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಹೊಂದಿರ್ತಾವೆ. ಯಾಕೆ? ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಬಿಕಾಸ್ ಆಫ್ ಸರ್ಫೇಸ್ ಟೆನ್ಷನ್. Upward movement of water in soils, that is also shown due to the surface tension, and hence the surface tension shows all these three, and hence option D, that is all the above, is the right answer. Sixth one, generally liquid drops assume spherical shape because as you know, the spherical shape is obtained because the sphere has minimum surface area. Sphere the surface area ಏನಿರುತ್ತೆ? minimum ಇರುತ್ತೆ, and hence option B is the right answer. Due to the minimum surface area of sphere, the liquid drops assume spherical shape. Seventh one, on heating a liquid, its surface tension, what happens to its surface tension? With increase in temperature, upon heating the temperature gets increases, and hence intermolecular forces gets decreases, and hence the tension on the surface gets also decreases. Therefore option B is the right answer. Ninth one, water drops stick to a glass surface due to. ವಾಟರ್ ಡ್ರಾಪ್ಸ್ ಗ್ಲಾಸ್ ಸರ್ಫೇಸಿಗೆ ಏನಾಗ್ತಾವ್ರಿ? ಸ್ಟಿಕ್ ಆಗಿರ್ತಾವೆ, ಅಂಟ್ಕೊಂಡಿರ್ತಾವೆ. ಯಾಕೆ? ಬಿಕಾಸ್ ಆಫ್ ಆಪ್ಷನ್ ಎ, cohesion. ಸೊ ವಾಟ್ ಈಸ್ cohesion means? Cohesion means the force of attraction which is present between the particles of same substance. ಒಂದು ಸೇಮ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಒಳಗಿರುವಂಥ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸಿಗೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? cohesion ಅಂತ ಹೇಳ್ತೀವಿ. ಆ್ಯಂಡ್ ಹಿಯರ್ the water drops are sticking to glass. ಅಂದ್ರೆ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಗ್ಲಾಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗೆ ಏನಾಗ್ತಾವು? ಅಟ್ರಾಕ್ಟ್ ಆಗ್ತಾವೆ. ಬಟ್ ಕೊಯಿಷನ್ ಅಂತ ಹೇಳಿದ್ರೇನು? ಸೇಮ್ ಸಬ್ಸ್ಟೆನ್ಸ್ದ ಪಾರ್ಟಿಕಲ್ಸ್ ಏನಾಗಬೇಕು? ಅಟ್ರಾಕ್ಟ್ ಆಗಬೇಕು. ಸೊ ದಿಸ್ ಈಸ್ ದಿ ರಾಂಗ್. ದೆನ್ ಆಪ್ಷನ್ ಬಿ, adhesion. Adhesion means the force of attraction which is present between the particles of one substance and another substance. ಸೊ ಟೂ ಡಿಫ್ರೆಂಟ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಒಳಗಿರುವಂಥ ಪಾರ್ಟಿಕಲ್ಸ್ ನಡುವೆ ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ಅಡೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಹಿಯರ್ ಟೂ ಡಿಫ್ರೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆರ್ ಅಟ್ರಾಕ್ಟಿಂಗ್ ವಿತ್ ಈಚ್ ಅದರ್, ಆ್ಯಂಡ್ ಹೆನ್ಸ್ ಆಪ್ಷನ್ ಬಿ ಇಸ್ ದಿ ರೈಟ್ ಆನ್ಸರ್. 10th one, the internal resistance to flow in liquid is called. As you know, the resistance to the flow of liquid is said to be viscosity. Therefore option C is the right answer. 11th one, with rise in temperature, viscosity of a liquid, what happens to the viscosity? As you already studied, with rise in temperature, intermolecular forces gets decreases, and hence viscosity will also decreases. So option B is the right answer. The 12th one, with increasing molecular weight of a liquid, the viscosity. So as molecular weight increases, the viscosity of the liquid gets increases because movement gets restricted, and hence resistance will be more, and therefore the increasing molecular weight is directly proportional to viscosity, and therefore option B is the right answer. That is, increase in molecular weight increases the viscosity.
13th question. The pressure exerted by 6 gram of methane gas in a 0.03 cubic meter vessel at 129 degrees Celsius is, given that atomic masses of carbon is 12, hydrogen is 1, and the value of R is equal to 8.314 kilopascal dm cube per Kelvin per mole. So what they have asked? They asked you to calculate the pressure which is exerted by 6 gram of methane gas. 6 gram of methane gas ಎಷ್ಟು ಪ್ರೆಷರನ್ನು ಎಕ್ಸರ್ಟ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಆ್ಯಂಡ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದಿ ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಾರ, ಎಷ್ಟು ಗ್ರಾಮ್ ಮಿಥೇನ್ ಅಂತ ಕೊಟ್ಟಾರ, ಮತ್ತು ಟೆಂಪ್ರೇಚರ್ನು ಕೊಟ್ಟಾರ. ಅಲಾಂಗ್ ವಿತ್ ದ್ಯಾಟ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆರ್ ಈಸ್ ಆಲ್ಸೋ ಗಿವನ್, ಆರ್ದ ವ್ಯಾಲ್ಯೂನು ಕೊಟ್ಟಾರ. ಸೊ ಫಸ್ಟ್ ರೈಟ್ ಡೌನ್ ದಿ ಗಿವನ್ ಥಿಂಗ್ಸ್. ಫಸ್ಟಿಗೆ ಏನು ಮಾಡಿರಿ, ಏನೇನು ಕೊಟ್ಟಾರ ಅನ್ನೋದು ಬರ್ಕೋರಿ. ಫಸ್ಟ್ ವಾಟ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್, pressure exerted by 6 gram. So mass is nothing but W is equal to 6 gram. Okay, 6 gram of methane is given. And volume is how much? 0.03 cubic meter. That is also they have given. Now, what is the value of R? R is equal to 8.314 kilopascal dm cube per Kelvin per mole. So now see the value of R and its unit. It is given in terms of dm cube. Value of R ಎದ್ರೊಳಗೆ ಕೊಟ್ಟಾರ, dm cube ಒಳಗೆ ಕೊಟ್ಟಾರ. dm cube means decicubic meter. And here volume is given in cubic meter. ಇಲ್ಲಿ cubic meter ಒಳಗೆ ಕೊಟ್ಟಾರ, ಇಲ್ಲಿ decicubic meter ಒಳಗೆ ಕೊಟ್ಟಾರ. So first you have to convert this cubic meter into decicubic meter. How you will convert that? That can be converted by simply multiplying with 10 raised to 3. 10 raised to 3 le multiply ಮಾಡಿದ್ರೆ, that is multiply by 1000. 1000 le multiply ಮಾಡಿದ್ರೆ, then you will get the value in decicubic meter. Okay, so remember this. If they have given in dm cube, then you have to convert that into dm cube by multiplying that with 10 raised to 3. Suppose cubic meter ಅಂತ ಅಷ್ಟೇ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ಅವಾಗ ನೀವೇನು ಮಾಡಬೇಕು, ಆಸ್ ಇಟ್ ಈಸ್ ವಾಲ್ಯೂಮನ್ನು ಇಡಬೇಕು. ಓಕೆ, ದೆನ್ ಅಲಾಂಗ್ ವಿತ್ ದ್ಯಾಟ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದಿ ಟೆಂಪ್ರೇಚರ್. ವಾಟ್ ಈಸ್ ಟೆಂಪ್ರೇಚರ್? It is 129 degree Celsius. But you have to convert that into Kelvin because it is given in per Kelvin. Okay, so Kelvin, how you will convert? 129 plus 273 is equal to how much it gives? It gives 402 Kelvin. Okay, now what you need to find? P, that is pressure, is equal to question mark. So which formula you are going to use here? ಯಾವ formula use ಮಾಡ್ತೀರಿ? As they have given VRT, you need to use the formula PV is equal to nRT. So it is ideal gas equation. This formula you have to use. But here V is known, R is also known, T is also known. ಅವು ಮೂರರದ್ದು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಾರಿಲ್ಲ, ಪ್ರೆಷರ್ ಅಷ್ಟು ಕಂಡುಹಿಡಿಬೇಕು. ಬಟ್ ವಾಟ್ ಈಸ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎನ್? ಈಗ ಪ್ರೆಷರ್ ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ ಎನ್ನದ ವ್ಯಾಲ್ಯೂನು ಗೊತ್ತಿರಬೇಕು. So find the value of N. N means number of moles. So how you will find the number of moles? Number of moles hang find out ಮಾಡ್ತೀರಿ? W divided by capital M. That is, W means given mass and capital M means molar mass. So which gas is given? Methane gas is given. What is the formula of methane gas? CH4. So given mass is 6 gram divided by molar mass is how much? Carbon, its atomic mass is 12 plus hydrogen, its atomic mass is 1. How many hydrogen atoms are there? 4. So into 4. So how much you will get? You will get 16. So molar mass is 16. Now substitute the value of N, R, T and V. You will get the answer. So first I need P. So P is equal to nRT divided by V. Cross multiply the V here. So substitute the values now. N means how much? 6 divided by 16 into R is how much? 8.314. 8.314 into T is 402 Kelvin whole divided by volume. Volume is how much? 0.03 into 10 raised to 3. So how much you will get? On simplification, you will get the value as 41,777 Pascal. Okay, because the pressure is given in terms of Pascal. So it is Pascal. So which option is right? From the following options, option D is the right answer. Option D is the correct answer. The next question, that is 14th one. If 10 raised to minus 4 dm cube of water is introduced into a 1 dm cube flask at 300 Kelvin, how many moles of water are in the vapor phase when equilibrium is established? Again ಮಾಡಿರೋರು 10 raised to minus 4 dm cube of water ಅನ್ನು 1 dm cube flask ಒಳಗೆ ತಗೊಂಡಾರ. ಟೆಂಪ್ರೇಚರ್ ಎಷ್ಟದ ರೀ? 300 Kelvin. So how many moles of water are in the vapor phase when equilibrium is established? Equilibrium ಇದ್ದಾಗ ಎಷ್ಟು moles of waters vapor phase ಒಳಗೆ ಇರ್ತಾವೆ, ಅದನ್ನು ನೀವೇನು ಮಾಡಬೇಕು? ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಗಿವನ್ ಏನು ಕೊಟ್ಟಾರ? vapor pressure of H2O at 300 Kelvin is 3170 Pascal and value of R is 8.314 joules per Kelvin per mole. Now you need to find the number of moles. Again, first write down what are the given things. ಏನೇನು ಕೊಟ್ಟಾರ ನೋಡ್ರಿ. So volume is how much? It is V is equal to 10 raised to minus 4 dm cube. Okay, 10 raised to minus 4 dm cube. And it is introduced in 1 dm cube flask at a temperature of 300 Kelvin. ಎಷ್ಟು ಟೆಂಪ್ರೇಚರ್ ಮೇಂಟೈನ್ ಮಾಡ್ಯಾರ್ರಿ? 300 Kelvin. How many moles? That is N is equal to question mark. And given vapor pressure, that is nothing but P is equal to 3170 Pascal. 3170 Pascal. Now, which formula you are going to use? Again, same formula, that is PV is equal to nRT. Because you need to find the value of N and value of R is also given. What is the value of R? 8.314 joules per Kelvin per mole. Okay. Now find the number of moles. How you will find the number of moles? N is equal to PV divided by RT. Substitute the values in the equation. P is how much? 3170 Pascal into volume is how much? 10 raised to minus 4 divided by R is 8.314 into T is how much? It is 300 Kelvin. So upon simplification, how much you will get? You will get 1.27 into 10 raised to minus 3. So that is the number of moles. This much number of moles of water are present in vapor phase. So which option is right? Again, option D is the right answer. 15th question. By what factor does the average velocity of a gaseous molecule increase when the temperature is doubled? So, ಏನು ಕೇಳಾರವರು ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಆಫ್ ಗ್ಯಾಸಿಯಸ್ ಮಾಲಿಕ್ಯೂಲ್. ಸಪೋಸ್ ಈಗ ಟೆಂಪ್ರೇಚರ್ ಇನಿಷಿಯಲಿ ಟಿ ಇತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದನ್ನು ಡಬಲ್ ಮಾಡಿದಾಗ ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಎಷ್ಟು ಟೈಮ್ ಹೆಚ್ಚಾಗುತ್ತೆ? ಆ್ಯಸ್ ಯು ನೋ, ಆ್ಯಸ್ ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್, average velocity of the gaseous molecules increases because of increase in kinetic energy. So first write down the temperature, initial temperature, that is T1 is equal to T. Starting temperature ಏನದ ಅಂತ ತಿಳ್ಕೊರಿ, T ಅದ ಅಂತ ಹೇಳಿ ತಿಳ್ಕೊರಿ. Then final temperature is T2 is equal to 2 times that of T. ಎರಡು ಪಟ್ಟದ ಅಂತ ಹೇಳಿ ತಿಳ್ಕೊರಿ. ದಟ್ ಈಸ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಡಬಲ್ಡ್ ಅಂತ ಹೇಳ್ಯಾರ. ಡಬಲ್ಡ್ ಅಂತ ಹೇಳಿದ್ರೇನು, ಇನಿಷಿಯಲ್ ಟೆಂಪ್ರೇಚರ್ಕಿನ 2 times ಹೆಚ್ಚಿರಬೇಕು. ಸೊ ಹಿಯರ್ ಇನಿಷಿಯಲ್ ಟೆಂಪ್ರೇಚರ್ ಇಸ್ ಟಿ ಆ್ಯಂಡ್ ಫೈನಲ್ ಟೆಂಪ್ರೇಚರ್ ಈಸ್ ಡಬಲ್ ದಿ ಇನಿಷಿಯಲ್ ಟೆಂಪ್ರೇಚರ್. ದೆನ್ ವಾಟ್ ಈಸ್ ಎವರೇಜ್ ವೆಲಾಸಿಟಿ? ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಅಂತ ಹೇಳಿದ್ರೇನ್ರಿ, ಇಟ್ ಈಸ್ ಗಿವನ್ ಆ್ಯಸ್ ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಈಸ್ ಈಕ್ವಲ್ ಟು, ಹೌ ಯು ರೈಟ್ ದ್ಯಾಟ್? ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಫ್ 8 RT divided by pi m. Now here two different temperatures are there. So write down initial average velocity, that is V1 at temperature T1 is equal to, ಯಾವ ರೀತಿ ಬರಿಬೋದು? 8 RT1 divided by pi m ಅಂತ ಬರೀತೀರಿ. Then final temperature, that is V2 is written as 8 RT2 divided by pi m. ಹೌದಾ? Now take the ratio, that is V2 divided by V1 is equal to how much? Square root of 8 RT2 divided by pi m divided by 8 RT1 divided by pi m. So what will get cancelled out here? 8R pi m, 8R pi m. They will get cancelled out. What will remain? Square root of T2 divided by T1. Now, as you know, V2 by V1 is equal to square root of T2 divided by T1. What is T2? T2 is 2T. And V1, that is T1 is how much? It is T. So how much you will get? You will get 1.41. Why? Because T get cancel out. Square root of 2 is 1.41. So which option is right here? Here option D is the right one. So 1.41 times the average velocity of the gaseous molecules will get increases. 16th one. Two gases A and B having the same volume diffuse through a porous partition in 20 and 10 seconds respectively. The molecular mass of A is 49 U. Molecular mass of B will be. Again ಕೊಟ್ಟಾರಲ್ಲೇ ಟೂ ಗ್ಯಾಸಸ್ ಅದಾವ, A and B. ಹೌದಾ? ವಾಲ್ಯೂಮ್ ಏನದ? ಸೇಮ್ ಅದ. ಓಕೆ. ಆ್ಯಂಡ್ ದೇ ವಿಲ್ ಡಿಫ್ಯೂಸ್ ಥ್ರೂ ಎ ಪೋರಸ್ ಪಾರ್ಟಿಷನ್, ಅಂದ್ರೆ ಸ್ಮಾಲ್ ಹೋಲ್ ಥ್ರೂ ಏನಾಗ್ತಾವು? ಪಾಸ್ ಆಗ್ತಾವೆ. ಎಷ್ಟು? ಗ್ಯಾಸ್ ಎ 20 ಸೆಕೆಂಡ್ ಟೈಮ್ ತೊಗೊಳುತ್ತೆ ಕಂಪ್ಲೀಟಾಗಿ ಪಾಸ್ ಆಗ್ಬೇಕಂದ್ರೆ. ಗ್ಯಾಸ್ ಬಿ ಎಷ್ಟು ಟೈಮ್ ತೊಗೊಳತ್ರಿ? 10 seconds ತೊಗೊಳುತ್ತೆ ಆ ಕಂಪ್ಲೀಟ್ ಪೋರ್ ಥ್ರೂ ಪಾಸ್ ಆಗ್ಬೇಕಂದ್ರೆ. ದಿ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆಫ್ ಎ ಈಸ್ 49. ಎದ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಎಷ್ಟದ? 49 ಅದ. ಬಿದ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಎಷ್ಟದ? ಅದನ್ನು ನೀವೇನು ಮಾಡಬೇಕು? ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಹೌ ಯು ವಿಲ್ ಫೈಂಡ್ ದಿ ರೇಟ್ ಆಫ್ ಡಿಫ್ಯೂಷನ್? ರೇಟ್ ಆಫ್ ಡಿಫ್ಯೂಷನ್ ಈಸ್ ಗಿವನ್ ಆಸ್ ಯು ನೋ, R is inversely proportional to square root of m. ಅಂದ್ರೆ ಮೊಲಾರ್ ಮಾಸ್ ಹೆಚ್ಚಾದಷ್ಟು ರೇಟ್ ಆಫ್ ಡಿಫ್ಯೂಷನ್ ಏನಾಗುತ್ತೆ ರೀ? ಸ್ಲೋ ಆಗುತ್ತೆ. ದ್ಯಾಟ್ ಯು ಆಲ್ರೆಡಿ ನೋ. Now rate of diffusion of gas A will be equal to, how you can write? Square root of 1 divided by ma, or you can write 1 divided by square root of ma. And rate of diffusion of gas B will be square root of 1 divided by mb. Now use this formula. What you will get, RA divided by RB is equal to square root of what you will get, MB divided by MA. Okay. Now what is the rate of diffusion of A? The volume is taken as V divided by how much time it will takes? It will takes 20 seconds. Rate of diffusion ಏನು ಮಾಡ್ಬೋದು, volume of gas passed divided by time taken is equal to 20 whole divided by RB is, it is having a same volume, therefore V divided by how much time it will take, gas B will take 10 seconds, gas B 10 seconds ತಗೊಳುತ್ತೆ, is equal to square root of MB molecular mass of B that you need to find, ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. MA ಎಷ್ಟದ ರೀ, it is 49. So simplify this, how much you will get, V get cancels, 20 and 10 get cancels, 10 ones are 10 twos are. So how much you will get, 1 will come here, 2 will come down in the denominator. So 1 divided by 2 is equal to square root of MB divided by 49. So on simplification what you will get, MB is equal to square root of 49 is how much, it is 7. So here what you will get, 1 divided by 4 into 49. So here simply you can also take the squares on both sides. ಎರಡು ಕಡೆ ಸ್ಕ್ವೇರ್ಸ್ ಮಾಡಿದರೆ ಏನಾಗುತ್ತೆ ರೀ, ಇದು 1/2 ಇದ್ದಿದ್ದು 1/4 ಆಗುತ್ತೆ. ಇಲ್ಲಿ MB ಮತ್ತು 49 ಆ್ಯಸ್ ಇಟ್ ಈಸ್ ಉಳಿತಾವೆ, ಸ್ಕ್ವೇರ್ ರೂಟ್ ಅಷ್ಟೇ ಹೋಗ್ಬಿಡುತ್ತೆ. ಹೌ ಮಚ್ ಯು ವಿಲ್ ಗೆಟ್, on simplification MB value will be equal to 12.25. So that is the molar mass of the B, and hence option, which option is right here, option B is the right one, option B. Maximum deviation from ideal gas is expected from. So among these options, which one will show maximum deviation from ideal gas? Remember, higher the critical temperature, more easily will be the gas liquefier. Now, most easily liquefiable gases show larger deviations. Among these four, the gas which is easily liquefiable is ammonia, because in ammonia the hydrogen bond will be present and hence it is having high critical temperature. Therefore, it will show maximum deviation from ideal gas behavior, and hence option C is the right answer. 18th question, for gaseous state, if most probable speed is denoted by C star, average speed by C bar and mean square speed by C, then for a large number of molecules the ratios of these speeds are. So here they have asked you to find the ratio. So most probable speed, how it is denoted, it is denoted by C star. Okay, what is the most probable speed equation, that is given as 2RT divided by capital M. And how average speed is denoted, it is C bar, that is given as square root of 8RT divided by M into pi or pi M. And how the root mean square speed is denoted, it is denoted by C and it is given by 3RT divided by M, that you already know. Now take the ratio, that is C star ratio C bar ratio C. How much you will get, it is 2RT divided by M ratio square root of 8RT divided by pi M and ratio of square root of 3RT divided by M. So RT, RT, RT get cancel out. M will also cancel out. What will remain here? Well, it remains only 1 ratio square root of 4 divided by pi ratio square root of 3 divided by T, because here 2 ones are 2 fours are get cancels. So now what you will get, upon simplification you will get 1 ratio 1.128 ratio 1.225. So this is the ratio which is obtained by taking these three velocities. So which option is right here? Option C is the right one. 19th question. Which one of the following is wrong assumption of kinetic theory of gases? ನೀವು 7 ಪಾಸ್ಟುಲೇಟ್ಸ್ ಕಲ್ತೀರಿ ಕೈನೆಟಿಕ್ ಥಿಯರಿ ಆಫ್ ಗ್ಯಾಸ್ ಒಳಗೆ. ಅದರೊಳಗೆ ಇಲ್ಲಿ ಕೊಟ್ಟಂಥ ಆಪ್ಷನ್ ಒಳಗೆ ರಾಂಗ್ ಯಾವುದದ ಅದನ್ನು ನೀವೇನು ಮಾಡಬೇಕು, ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ಆಪ್ಷನ್ ಎ, ಮೂಮೆಂಟಮ್ ಆ್ಯಂಡ್ ಎನರ್ಜಿ ಆಲ್ವೇಸ್ ರಿಮೇನ್ ಕನ್ಸರ್ವ್ಡ್. ಎನರ್ಜಿ ಮತ್ತು ಮೊಮೆಂಟಮ್ ಲಾಸ್ ಆಗೋದಿಲ್ಲ, ಅವು ಯಾವಾಗಲೂ ಏನಾಗಿರ್ತಾವೆ ರೀ, ಕನ್ಸರ್ವ್ ಆಗಿರ್ತಾವೆ. ಯಾಕೆ? ಬಿಕಾಸ್ ದಿ collisions between the gaseous molecules are perfectly elastic and hence energy will remain conserved. So option A is the correct statement. Option B, pressure is the result of elastic collision of molecules with the container's wall. ಹೌದಾ? ಆ ಗ್ಯಾಸದ ಪ್ರೆಷರ್ ಎದಕ್ಕಿರುತ್ತೆ? ಬಿಕಾಸ್ ಆಫ್ collisions of molecules against the walls of the container. That is also the correct statement. Option C, molecules are separated by great distances compared to their sizes. ಹೌದಾ? ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆ್ಯಸ್ ಯು ನೋ ಗ್ಯಾಸ್ ಒಳಗೆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನಿರ್ತಾವೆ ರೀ, ಭಾಳ ದೂರ ಇರ್ತಾವೆ. ಗ್ರೇಟ್ ಡಿಸ್ಟನ್ಸಸ್ ಕಂಪೇರ್ಡ್ ಟು ದೇರ್ ಸೈಜಸ್. ಸೊ ಆಪ್ಷನ್ ಸಿ is also the correct statement. Option D, all the molecules move in straight line between collision and with same velocity. Is it right? Yes, all the molecules will move in a straight line, that we know. But after collision, the velocity of those gas molecules will get changes. ಆ ಮಾಲಿಕ್ಯೂಲ್ಸ್ದು ವೆಲಾಸಿಟಿ ಏನಾಗುತ್ತೆ ರೀ, ಚೇಂಜ್ ಆಗುತ್ತೆ. ಒಂದು ಫಾಸ್ಟ್ ಇರ್ಬೋದು, ಇನ್ನೊಂದು ಸ್ಲೋ ಇರ್ಬೋದು. ಸೊ ದಿ ವೆಲಾಸಿಟಿ ಈಸ್ ಡಿಫ್ರೆಂಟ್ and hence the option D is the wrong statement. So among these four, the wrong assumption of kinetic theory of gas is option D. So that is the answer. 20th question. Equal masses of hydrogen, oxygen and methane have been taken in a container of volume V at temperature 27 degrees Celsius in identical conditions. The ratio of the volumes of gases H2, O2 and methane would be. So here equal masses of three gases have been taken and also the volume is maintained at temperature 27 degrees Celsius in identical conditions. You have to find the ratios of the volumes of the gases. So take the ratios, that is H2, okay, ratio of O2 and methane, that is CH4. This ratio of these gases volumes you have to find. So how to find that? Apply the Avogadro's law, because they are maintained in identical conditions and they are all having the equal masses. Therefore, you know, according to Avogadro's law, volume is directly proportional to number of moles. So if you find the number of moles, you will also get the volume, and hence, so number of moles of hydrogen and number of moles of oxygen and number of moles of CH4 you need to find. How you will find? Given mass divided by molar mass of hydrogen, that is how much? 2. And number of moles of oxygen is given mass divided by molar mass of oxygen is 16, that is 16, and here 2 are there, so 32, make it 32. And number of moles of methane, that is given mass divided by atomic mass or molecular mass is 16. Therefore, volume of hydrogen, volume of oxygen and volume of CH4 is equal to number of moles of hydrogen, number of moles of oxygen and number of moles of methane. So how much you will get now? That is W divided by 2 ratio W divided by 32 divided by W divided by how much? 16. So take the LCM, W get cancel out. So you will get 16 ratio 1 ratio 32. Sorry, 2. Okay. It is because 16 into 2 is 32 32 into 1, 32. 2 into 16 is 32. So on taking LCM, you will get 16 ratio 1 ratio 2. That is the answer. So which option is right? Option C is the right answer. 21st question. The ratio of masses of oxygen and nitrogen in a particular gaseous mixture is 1:4. The ratio of number of their molecules is. So you need to find the ratio of their number of molecules. So simply find the number of moles here also. So number of moles of oxygen, number of moles of oxygen is equal to, how you will calculate, given mass divided by molecular mass, and number of moles of nitrogen is equal to given mass divided by, again it is molecular mass. And here how you will calculate it? So here the ratio of the nitrogen is 4 times of the oxygen, and hence 4 times D into W given mass divided by 28. So again on simplification, what you will get? W divided by 7, because 4 on the 4 7 is 28. Now ratio, therefore ratio of these molecules will be W divided by 32 ratio W divided by 7. Again taking the LCM, what you will get? 7 ratio 32. So which option is right here? Option B will be the right answer. 22nd, a gas such as carbon monoxide would most likely to obey the ideal gas law at. So as you know, the real gas, carbon monoxide is a real gas. At what conditions it will obeys or it will shows the ideal gas behavior? So option A, high temperatures and low pressures. Here as you know, the real gases shows ideal gas behavior only at high temperatures and low pressures. So option A is the correct answer. The remaining options are wrong answers. So option A is the right one. 23rd, a closed vessel contains helium and ozone at pressure of P atm. The ratio of helium and oxygen atoms is 1:1. If the helium is removed from the vessel, the pressure of the system will reduce to 2. Since, as we know, the ratio, okay, of helium and ozone means O3 is how much? 1:1. The ratio of their moles will be written as 1:1 divided by 3, because O3 is there and helium is 1. So 1:1 divided by 3 when they are present in 1:1. The number of moles will be 1:1 divided by 3. So total moles is equal to, total moles estagatri 1 plus 1 divided by 3, that is equal to 4 divided by 3. So total pressure is how much? P, and hence pressure of O3 will be 1/3 divided by 4/3 into total pressure, that is mole fraction. So here pressure of O3 is equal to 0.25 P. This is the answer. Remember, here we have removed the helium. Helium ಅನ್ನು ರಿಮೂವ್ ಮಾಡಿದ್ಮೇಲೆ ಎದ್ರದ್ದು ಪ್ರೆಷರ್ ಉಳಿತದ್ರಿ? ಓಝೋನದ್ದು ಪ್ರೆಷರ್ ಅಷ್ಟೇ ಉಳಿತದ. ಸೊ ಅದರದ್ದು ಪ್ರೆಷರನ್ನು ನೀವೇನು ಮಾಡಬೇಕು? ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಹ್ಯಾಂಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಿ? ಟೋಟಲ್ ಪ್ರೆಷರ್ into mole fraction, that gives partial pressure of ozone. So partial pressure is equal to mole fraction into total pressure. That formula I have used, and upon adding the values you will get 0.25 P. So which option is right? Option A is the right answer. The factor that has the largest effect on vapor pressure of liquid is, ಯಾವ ಫ್ಯಾಕ್ಟರ್ ಲಾರ್ಜ್ ಎಫೆಕ್ಟನ್ನು ತೋರಿಸುತ್ತೆ. ಎದ್ರ ಮೇಲೆ? ವೇಪರ್ ಪ್ರೆಷರ್ ಆಫ್ ಲಿಕ್ವಿಡ್. ಸೊ ಒಂದಿಷ್ಟು ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಿರ್ತಾವೆ ಗ್ಯಾಸಸ್ದು ಹೈ ಇರುತ್ತೆ, ಒಂದಿಷ್ಟು ಲಿಕ್ವಿಡ್ಸ್ದು ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಿರುತ್ತೆ ಲೋ ಇರುತ್ತೆ. ಯಾವ ಬೇಸಿಸ್ ಮೇಲೆ ಹೈ ಅಥವಾ ಲೋ ಅದ ಅಂತ ಹೇಳ್ತೀವಿ? ದ್ಯಾಟ್ ವಿ ನೀಡ್ ಟು ನೋ. ಸೊ ಆಪ್ಷನ್ ಎ, ಲಿಕ್ವಿಡ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ. This will affects, but it does not affects to the large extent. So it is not right answer. So option B, molecular dipole moment. That is also not applicable. Option C, presence of hydrogen bonding. So this is the largest effect on vapor pressure of liquid, because if the hydrogen bond is there, then the vapor pressure of those liquids is very low if strong hydrogen bonding is there. If weak hydrogen bonding is there, then the vapor pressure of the liquid is high. So this is the largest effect on vapor pressure, and hence the presence of hydrogen bonding has the factor that has largest effect. So option C is the right answer. 25th, which of the following liquids has the highest viscosity? Option A, benzene. Option B, carbon disulfide. Option C, acetone. And option D, ethanol. So as you know, if the intermolecular force is strong, then viscosity is also very high. Among these four options, the ethanol will shows the intermolecular hydrogen bonding, and hence the strongest intermolecular attraction will be shown in ethanol, and hence it is having highest viscosity. So option D is the right answer.